Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we continue playing with our networked game. We've completed an RMI version. Now we're working on a regular networking version, and hopefully in this video we can finish all of that off. So in the last video we started building our socketed version of this, and for the most part we have it so that it sends messages. Okay? And the way we're sending our messages is we have an object output stream for each of the sockets, and we're writing objects to them. And so we've made these little case classes in here. We never actually tried running this to make sure that it will work. In the server, we made it so that main opens the server socket and accepts and then calls the connect function. This is the connect function we wrote previously, but we had to edit it so that it would work with a socket instead of using RMI, which means that how we come into it is also different here. And once two clients have connected, we stop at waiting for more clients, and instead we come down to start game. And this start game is effectively written here. Every time through, most of this code really is the same for the RMI version and the Telnet version, or sorry, and the socket version. This line right here wound up being a little bit different because we're sending these messages across, and then this line also changed. But there wasn't too much that was different here. There's just one problem. We are never getting into, in particular, these two methods right here. Okay? The connect happens anytime we accept a connection, so that's actually that was easy for us to do. But what should happen here? This turn left and this turn right should be coming as messages from the player, or from players. So the move is called locally. How do we get it so that code that previously was an RMI function call is going to happen in this setup? We need to have some thread that is running through and that every so often checks to see whether or not we have gotten a message. And it turns out that in this case, on the server side, we already have a thread that is happening at regular intervals. And so what we can do is, first thing up inside of here, we can call something like, how about read players, and let's go ahead and def read players up here. What I want this to do is I want it to run through each of our clients. So for C in clients, and we want to check to see if they have something on their input stream. So if c dot object input stream dot available is greater than 0, in other words we have some type of message sitting there waiting for us, then what we want to do is c dot object input stream dot read object. Now, as you hopefully recall from some of the earlier videos, read object returns to us a Java object, which is an anyref type in Scala. So we need to know a little bit more information here. So I want to match that on the possible different cases. What are the things that we're expecting to get from our client? Well, it turns out this is fairly simple. We have one case for I'll call it TL, which is actually let's use a pattern matching here. Turn left. This would be one of the reasons for using a case class, because I can use pattern matching. And this is, the turn left is inside of the socket Tron client. Okay, ent dot turn left. And what happens here? Well, if I get a turn left from that player, I call turn left on P. And if we get a turn right, we want to turn right on P. And so this is going to happen every time through. We will check to see for each client, do they have something available? If they have something available, we will read it. The only messages right now that our clients send out, the only things that we write to the object output stream are right here, okay, where we write these things. Otherwise, the players are just receiving messages. So this kind of closes the loop on the server side. Now the server is writing stuff out regularly, and it also has the ability to read stuff in. The client currently is writing stuff out here, but it's not reading stuff in. We never call game start, we never call game ends, and we never call step taken. So what we want to do is inside of here in our main method, we want to simply have this wait for and get messages from the server. So up at the top here, we opened our socket and our input stream and our output stream, but we're not using that input stream really. So what I'm going to do here is, how about I just go while, no, I don't need to go while true. Let's create a flag. Flag equals true while flag. We'll make it so that our main method stops if it gets a game ends message. What we're going to do inside of here is simply go the object input stream, read object, match on our cases for what are the things that we can receive. Well, we can receive any of these case classes that we defined up at the top. I'll go ahead and copy those over. So we have one case for a countdown which takes a value. We have another case, and these should all be socket Tron server. Copy, paste, paste. Oops. Okay. Step taken just gets the two sequences, P1 and P2. We don't really care what type of sequence they are. And this gets a winner. Okay. And so if we get these things, we need to call the appropriate methods. Game start of value, because that's what countdown was supposed to do. This sending countdown replaced our RMI call to game start. Sending step taken replaced our RMI call to step taken, and it passes P1 and P2. And why is this unhappy? Oh, because I can't spell. Okay, and then if we get the game ends, we call game ends on the winner, and I'll go ahead and hit enter here because I also want this to say flag equals false. Okay, now it would appear that the cycle is connected over here. Let's see what this does. So if we run the server, our server is up, hasn't crashed. If we run our first client, the first one runs. I see no window though yet. That might become a problem in just a second. Start the second one. Okay, so nothing present, nothing happening. Both of our clients, they came up. I'm going to bet that let me think about this for a second. When you open an object input stream or an object output stream, it actually writes something or reads something in the case of the input stream. So I'm going to, as soon as I open these, because I buffered them, I'm going to flush them, and I want, you notice in addition to flushing them, I swapped the order of these so that the server opens its output stream first, at which point this opens its input stream, and then the server goes and opens its input stream, at which point this opens its output stream. Okay, and then we got through the read, and we get one window up. And we get through another one, and we get another window up. But nothing is happening. There was an exception on the client side. Match error up. Okay, well that's because we are... I don't have a general case here to accept everything else. Okay. But the bigger question is why our server doesn't start running. Actually, let's put a print statement in the server. Game running. All of these for each, when we write things, it would probably be better to make sure that we immediately flush afterwards. Rocket p dot because otherwise we risk things getting hung up. Because they are buffered. Now, technically I could probably get rid of the buffering and then I wouldn't necessarily have that problem. On the other hand, some of these messages, like first step taken, are fairly large, and I just feel more comfortable having the buffering in there. Okay. Oops. Why is it not giving me a Scala application? Oh, that's kind of a pain. Weird. What about this one? So that one still knows that it's a Scala application. Okay, now this one does too. Okay, so the server's up. One client, it gets through, it opens a window. Another client, 4, 3, 2, 1, 0. Game running, clearly I am not repainting or something in here. You won, you lost. Well, that was interesting. Okay, so where is the breakdown? This is, so the game running was happening over and over again. I can take out that print line. We don't need that to see that it was working. And it is writing to the client that the step is taken. And over here, step taken, if received, is supposed to call a step taken. We know that it got the countdown messages. We know it got the game ends message because it printed those things. So if it's getting a step taken, oh, wow, yes. This is going to be a slightly more challenging one. Okay, so here is the problem that we're facing on this. And this is the first time I ever ran into this bug, it took a long time to fix, because quite honestly, everything in our code looks fine. In fact, at a certain level, everything in our code is fine. The only problem is if you go digging into the API, you find that when you do a write object, if the object that it writes has already been written before, it will use the old version of it. It's a good optimization. It turns out that serializing objects is a lot of effort. The only problem here is that we have these mutable objects, P1 and P2, and I want to write the new versions of P1 and P2, not write the old versions. And so what you saw was the lines didn't get any longer because it kept sending the original versions of P1 and P2. And I don't want to do that. So let's do it this way. Pull up the API, see how long that takes. Because I wasn't seeing the name of a method that just jumped out to me and said, this is what you want. So we go to java.oracle.com, and inside of the Java APIs, Java 7, java.io, I want an object output stream, because the object output stream is what does the buffering. Okay, I believe it is the reset call in there. I wasn't certain when that popped up earlier. So let's try that. Make sure all of our processes are stopped in the server. We run the server. We run one client, and the window pops up. We run another client, and we start getting a countdown. And the question is, do the lines grow longer? Yes, they do. But my arrow keys are not turning the bikes, so clearly we have another error to deal with. This one would be on the server side, and essentially, so on the client side, I think we can feel fairly confident this code should be going through. We weren't 100% certain. Print line, turn left, print line, turn right. Now over on the server, this is happening inside of read players. Whoops, I know why. At least I think I do. Same problem with flushing. At this point, some people watching this might go, wow, we should just get rid of those buffers. I've been bitten by the performance of unbuffered streams though, so I really do prefer to have buffering whenever whenever it's an option, even if it does require me to do a little bit more work at times. So why do I need to flush those? Well, it turns out those particular messages were pretty small, so I was unlikely to fill the buffer. No, that's still not it. And of course I erased my code, print line, turn left, print line, turn right. Over here, read object, if it reads turn left, restart the server, first client, second client, 4, 3, 2, 1. So I'm getting those on the client side. There's no problem there. Definitely getting through that part. But on the server side, there was nothing. And so the question then becomes, how can the client side send objects through its output and flush it? And of course it got here because it was doing the prints, but the server never hits this. Is there any possibility that this is unhappy? And I can't, well, okay, I could. I kind of like the idea of having it inside of the main loop and just happen every so often. And then it works off of each client's object input stream, checks it, how many bytes are available. I could start, if I started this off in a different thread, I wouldn't have to check the is available. The problem is if I do a read object in the main thread, the read object is going to block. So that's why I don't want to read objects until there's something available. And the object input stream. Well, it is not immediately obvious to me why this is, so I will have to pause here and come back for probably one more video where I fix this up. See you again soon.